Yeah. Yeah. Uh. Yep. Okay. I can send you a link to the event in just a sec. Um. Yeah. Okay. Yep. Uh. Yeah. Okay. Yeah. Any what? So the place around corner doesn't have vegan pizza currently. Um, yeah, wait just a sec. Yeah. Okay, Kangar, if you want to start your presentation, go ahead. I'll get at everything working on this end. Yeah.
All right.
Yeah.
So I'll just
Yeah.
go ahead and share my screen.
Go ahead.
Okay, everyone can see double now.
Yeah. Yeah, wait just a sec. I need to full screen it. Uh, full screen. Yeah. Uh, yeah, okay. Wait just a sec. I'm getting everything there. Okay. Yeah. So if you're ready, you can go ahead.
Yeah. So um, I think it's not possible that you can also see my camera, right, in Discord? You
Uh,
can only get my screen or my camera.
or I can probably pull up video participants, but it makes the screen a lot smaller.
Yeah, no, it's fine. It's fine. I mean, I'm fine with that. It's 3 a.m. here. I'm looking very tired, anyways.
Yep. Yeah. Still, go ahead.
Wonderful. So, looking at the screen, I see there are a bunch of real people out there meeting. That's great. I'm really happy you can have that nowadays again. So thank you very, very much for inviting me. It's a great honor. Um, I my name is Marius, aka Kangar on Discord. I am a PhD student in Technical University Berlin, and I am also now the VR AR Brain Computer Interface lead at Xander Labs. And today I will be speaking about my Skyrim VR mod called Real Virtual Magic, and I will also be giving a little bit of a background about my research and about my vision or our vision about virtual reality and brain-computer interfaces. Also, feel free to ask questions in the chat on YouTube. I can actually read the chat on YouTube on my phone, so that's fine. And also, obviously, questions all good. I'm very easy to interrupt. Okay. So I'll start with a little teaser, which is our journey from, and then you just press C to vibrate with me. And I promise that will make sense in a second. So I'm not sure if you can hear the sound of this. I don't think so. Can you hear anything?
Yeah, so the audio isn't working. You have to share the app instead of the screen. Um,
Well, that's too bad.
uh, yeah,
Let me check. Can I do that quickly, or is it a...
yeah, so he can't hear you. Uh, yeah, so where it says screen, click on that for a screen share, and it should bring up change windows. Um, yeah, and then make sure it's application yes, and try doing that, and let's see if it works this time. Yeah. Yep,
I
it's
don't seem to
working.
hear.
It's
It's working?
working.
Wonderful. Perfect.
Finally arrived. Welcome to the School of Holy Magic. Now listen. It's not easy to master these skills, but I believe in you. The first spell I shall teach you is Holy Fire.
I'm ready.
You must align your soul with your actions. You must strive to find perfect balance. Focus your mind. Do you hear me vibrate with you? Vibrate with me. Spirits, come to me. Come to me and allow me to enter into his body so he may understand. To feel the magic go through your veins. Do you understand me? Breathe in the crisp air of nature. And then you just press say.
What was it about?
Press say.
Press C.
You must find perfect balance. You feel that? You feel at
balance,
one
yeah.
with nature around you. The holy magic coursing through your veins.
Okay, so that is basically it. I assume you saw, you heard everything. I actually couldn't hear it myself. It's a little weird, apparently, in Discord. But yeah, so this is the issue, right? As a gamer, we know this, right? So magic in games is always a little stale. It just doesn't work as well, and you don't really have that feeling that you are the magician. You rather press a button, and essentially what I'm trying to solve is exactly that issue. So I want to have the feeling that you need to connect with your inner feelings, with your inner power. And that is what I created, or what I had in mind when I created this Real Virtual Magic mod. Looking at the stream, it seems like there's only a blank page for you. Is that true?
That is correct currently. I am only seeing a blank page. Oh, something just came up. Yeah.
Does it say real virtual magic now?
No, it went back to the blank page.
Damn it.
Yeah. Huh.
I'll go back to sharing my entire screen.
Or, yeah, huh. Maybe, yeah. Check, yeah. Okay, yeah. It's working
That's,
now.
that's working nice.
Yeah.
Wonderful. Okay, so back. So this is the idea that I had in mind with this real virtual magic mod, right? You can see me here to the left wearing a VR headset and a Muse, in this case a Muse 2 headband. And I nowadays recommend more using the Muse S, but I'm coming to that. And to the right, you can see a screenshot from what it looks like in the game. So this is the Real Virtual Magic mod available for download on the Nexus mod page. And I'll go into some more details about this whole thing later. But if you don't mind the detour, I would like to first go into some background, just to give you a little bit of an impression of what I'm actually working on in my day job. So basically what you can see here is a big blob of a lot of neuroscience research. And then here you can see a little bit smaller blob of brain-computer interfaces. And surprisingly, these don't overlap too much, actually. So brain-computer interfaces is more an engineering thing, whereas neuroscience research is more a basic science thing. And somewhere in between these two and a little bit more to the neuroscience research, there's the field of mobile brain-body imaging, which is more about mobile neuroscience. And really what I am trying to do and what I've been doing the last few years is bringing these fields a little bit closer together. And essentially that's where I'm going for. I want to be in that overlap between basic neuroscience, mobile brain-body imaging, and brain-computer interfacing. So taking a step back, looking at classic EEG experiment setup or neuroscience experiment setups, you have people sitting around at a desk and they look at a picture, for example, picture of a snake in 2D on the screen. Then they press a button whenever they see a snake, for example. And then you see you have a very limited stimulus, a very limited response. They both are not very lifelike, and that means that there is also some processing in the brain lacking. It doesn't mean that these experiments are invalid. It just means that they are lacking a certain aspect of cognition. And here is mobile brain-body imaging in the game. That basically means that we have participants that start to actively interact with the environment. So they are doing an active task in 3D, either in virtual reality or in real reality. And then meanwhile, we record brain and we record body data, and then we investigate the cognitive and affective effects in a naturalistic setting. So this is the field of mobile brain-body imaging. That's where I'm doing my PhD here at TU Berlin. And a little bit of a detour about embodied cognition in this case is that what we really want to have, or what we in reality had, if we saw a snake, was we stand there, there's a snake, we turn around and run away. So at least that's what I would do, because I have no clue which snakes are venomous and which are not. So yeah. And in this case, what we have is a much more rich processing going on. We have the world influencing our brain. We have the brain influencing the perception of the world, actually, in a top-down processes. We have the brain performing some actions through our body, and these actions are also perceived in our brain, and they have an effect on the world. So all the stuff going on is much more rich and interesting. And what we really want to have is this, and we also want to measure the brain in this large and complex environment. But in addition, we also need to measure the world and the actions, and then we have the full picture of what's going on, and we can make sense of our data. So if we really want to investigate the complete process, then we need to be mobile in our experiments, and we need to include more input and output modalities in our data recordings. We cannot just record brain. And that's what we are doing in mobile brain body imaging. We use virtual reality. So this is our tool in this case. We are not game developers, and I'm not a game developer, but we use virtual reality as a tool and perform our experiments there. And here we use, for example, the HTC Vive. Probably everyone has seen that. It has controllers, it has full room scale tracking, and it allows interacting with the world. And that means that we as experimenters have complete control over whatever the subject experiences. And we can change things however we want. We can make sure that nothing weird is happening for the participant, which is not the case in reality, because there's just too much going on. And luckily, the whole thing is compatible with brain imaging if you use electroencephalography, EEG, which is what we are doing. And the data that we get in the end is for the brain imaging high-density EEG. Here you can see 128 electrodes. So that's what I'm normally working with, is extremely high-density EEG, and doing source localization and all the fancy stuff that you can do with EEG. So it's really a very complex ordeal. It also takes hours to set it up, like literally 1.5 hours for every participant to set everything up and put the gel in and so on. It's quite a thing. And in addition to that, we record motion capture, for example, through the Vive SteamVR tracking, or through FaceSpace, which is a tracking system we have in our lab. And lastly, we also record eye tracking. So that can be, for example, the SMI eye tracker that we used in our HTC Vive. SMI is now bought by Apple, I think, a few years ago. So nowadays we would use something different, but that's a device we still have. And we can also record heart data and all kinds of other physiological data. And then in reality, an experiment looks a little bit like that, or at least this is what my experiment looks like. So you can see here the participant looking at bubbles floating towards them, and they have to touch the yellow bubbles, and they only show the colors whenever you actually look at them. You see the little blue dot, that's the eye tracker. And then, we can investigate different cognitive processes while looking at either of the two different stimuli. And we can also record all the movements and so on. So that is a proper mobile brain body imaging experiment. However, that's really boring. It's not a game, right? It's an experiment. It's great. It's much more fun for an experiment than regular experiments are. But still, yeah, it's a neuroscience experiment. Now, what's with the brain-computer interfacing, right? So that's really where I want to go. And the thing with brain-computer interfaces is that there are two types of BCIs, if you will. So classically, you have BCI for communication and control. To be very clear, there are more than two types of BCIs, but here I'm only discussing two. So classically speaking, you have BCIs for communication and control, either steering a wheelchair, for example, or communicating while you are locked in patient. So that's really where BCI started in the first place. For example, with the P300 speller, it's a very famous general experiment that many people are using and researching in, and lets you spell out words without speaking them, right? And another thing is motor imagery, trying to steer left and right or up and down by imagining wiggling either the left or the right hand or foot and so on. But there are other types of PCI, in this case passive PCIs, that really can detect other aspects of the user state. So it's not about communication and control, but it's about continuous measurement. So you don't actively interact with the PCI in this case, but it just runs passively while you are doing other stuff. And that, for example, means that it enables implicit control of a cursor. That's a really interesting paper here, and a bunch of other things. For example, you can also localize the processing, and there's really cool stuff going on. In this case, this paper allows the cursor just steering in the right direction without the participant actually doing anything actively, like imagining left, right, or up and down. The participant is just looking at the stuff, and the cursor learns where the participant wants the cursor to go just by the brain signals. And we can also detect workload. We can detect emotional states. There are a bunch of different things that you can detect with passive brain-computer interfaces. Much research is still going on here, and many things have to be finalized and improved here, obviously. But this is really where we want to go with BCIs as an active tool, not only for people like in the medical field, but really for everyday people who are using it, for example, in safety critical environments and so on. Now, this is still only brain-computer interfacing, using only electroencephalography in this case, but where I want to go personally is multimodal classification. So this is really making the full use of the mobile brain body imaging data, using motion capture, using eye tracking, using heart rate, whatever I can get my hands on, and use that for classification, use that in whatever I want to investigate, and with that, linking brain-computer interfacing and mobile brain body imaging. Essentially, I would like to borrow a sentence from Connor Russomano from OpenBCI. I've heard that in another talk he has given. I really liked it, and that is, I am not interested in the brain. And that's really true. I really am not interested in the brain. I'm interested in the mind. So whatever vehicle I can use to tap into the mind is fine with me. And in this case, especially in virtual reality, I can use motion capture and eye tracking, and these are very powerful. So here you can see papers where we can see that physiological data, EEG, eye tracking, and other physiological data can contribute to a classification of a workload task. And here this paper is just a classification of only motion capture, where many different movements could be classified very accurately with a classification accuracy that EEG research can only dream of, really. So then, putting everything together, we get VR brain-computer interfacing. So here, back to my experiment from before, we have the contact of the sphere. So whenever you touch a sphere, there's an event. And then we can put that event in and look at our data here. So in the brain, we can see, for example, for errors, different things happen than for correct touches. And then the same goes on for eye tracking, and also for controller. We can see clear responses moving around differently and looking around differently, if depending on the different event. And that is a relatively long title of multimodal mobile brain body imaging passive brain computer interface in virtual reality, which is really not very catchy. So if anyone can come up with a better name, I'm very happy to hear suggestions. But for now, I'll call it VR BCI. And now we're coming to the real important part, right? So I am a neuroscientist, as you say, as I said. I've been training for 6 years now in the university doing this, but essentially I'm a gamer at heart. I really do all that only because I want to do cool games. I am a very active member of the Skyrim VR community, modding and so on, and I really this movie that I've shown you in the beginning, that's really what drives me. I really want that, and this is why I created this VR BCI mod. But in general, I'm not the first person to do something with BCI and gaming. Obviously, there is a lot of research on adaptive gaming. So we have, for example, Tetris games that are adapting the difficulty level with the biocybernetic loop. which is another word for passive BCI. And there's another Tetris game which is completely hands-free, where the difficulty level is adapted with the BCI, and the eye tracking steers the oh no, how are they called again? The Tetris blocks. They have a name. I forgot. Sorry. Yeah. So yeah, this is what's happening here. And what I want to do is the whole thing in mobile virtual reality, right? So taking that to the real virtual magic VR context. Now here we finally arrive at the thing that I was advertising in the beginning. So this is the Skyrim mod where you can see, in this case, it's not yet the Skyrim mod, but it's even like a different demonstration, what you can see here to the right. It's a little Unity demonstrator that I made a while back, just giving an impression of the power that you can have here. So you can really just see that a game can tap into the BCI, and in that virtual world, your brain powers can have a direct influence. That is really what I want to have. So this would be actual magic, the closest we can come to actual magic, assuming that it isn't real in the real world. But in virtual reality, we can make it a thing that you can experience, and that's what I want to do. And for some reason, my computer is a little slow with the slides here. Anyway, so here what we can do is we use a VR BCI multimodal classifier, and then we can scale your magical powers by this factor coming from the classifier, from the multimodal classifier, not taking only BCI, not only taking EEG into account, but everything we can get in virtual reality. And then this classifier becomes an integral part of the gameplay. And this is really a key concept, right? So the key part of the gameplay, the integral part of the gameplay is what I'm going for, right? It should not be just a thing that you do on top, like many neurofeedback games are doing it, like something that obscures your screen if you don't focus or something like that. As a gamer, this is boring, right? I wouldn't want to do that. Like, I want to create something that's actually fun for the player. So this should be something that you cannot experience without the brain-computer interface. This is really, as I said, an integral part of the gameplay. It's an exclusive VR BCI game that you can only have if you have all the access to the mind powers in this case. And then, and only then, you can experience magic as though it was real. And the good thing is, while you're doing it, you are also kind of learning meditation along the way, because essentially this kind of inner focus and being able to keep up this inner focus while you're playing maybe an exhausting game, or while you're in a threatening situation, like learning to keep your wits about and to focus even if you're very excited about whatever's happening. That's really meditation in some sense. And now this is there. It's a Skyrim VR mod available for download. Just very quickly, Skyrim VR for people who don't know it is an open world role-play game where you have magic and you have dragons and swords and shields and arrows and bandits and whatnot. And it's a huge world, and it has a huge modding community. So that means you can get all kinds of weird stuff in the game. But one of this weird stuff is now Real Virtual Magic, which is a mod that lets you exactly do that. So I use the Muse 2 or the Muse S and interface it using BrainFlow, which is a fantastic toolkit created by Andre, which is just very powerful and very easy to use. directly interfaces with the Bluetooth of the Muse, and it really just works. There's not much more to say. It's nice to work with. I can wholly recommend checking that out. And then I have a self-made focus value that I calculate from the data I get from the Muse, and scale the magic power in the game by that value. That means you have more magicka available, and your power is also, like, your spells are more powerful, so you do more damage and you heal more. There are more features to come. One of them is, for example, that you do some self-harm if you are not very focused, but you start to cast a spell. That means you have unstable magic, and you hurt yourself in confusion. And there are more things I want to add here, but I didn't have the time yet. Yes, developing Skyrim mods is also a little complex. Luckily, I have lots of help from the community and the friends that I have there, but still it takes time. So yeah, if you really want to be a mage in Skyrim using this mod, you need to learn that. You need to learn how to stay calm, how to focus your magic, and then use it in the game. And this mod has also been featured quite in a lot of articles and some videos, also some YouTubers and so on. So it seems to get a lot of attention, which is great for me. It shows me that the thing that I am excited about, the thing that I want to see in the world, is also something that the world wants to see. So that's great. I'm very, very grateful for that. And I have an Discord server here with a relatively active community with now over 700 members already. And the cool thing is that it's really also a lot of scientists and game developers there that are interested in the whole thing. And I invite you to join too. I will send you show the link later on. So this is a little impression of the video of the mod. You can see here that you can see the brain power at the very bottom of these 4 bars, and me just goofing around playing like burning these bandits. I am level 1 here, so I am really weak, or I should be really weak, but I am just taking the hits and still burning them away, because in the beginning I had lots of brain power, and now at the end you can see the brain power is reduced. Importantly, this reduction in brain power was not from the game. That was the measured brain power. So then afterwards I need to take a rest and focus again, and the brain power starts to fill up again, and I regenerate more magicka. So this is really important here. The purple bar is not influenced by the game. The purple bar is influenced only by the power that I derive from the Muse as data. So if it goes up, that's because the brain power goes up, and if it goes down, that's because, yeah, you didn't focus. And just dropping this here too, it's very easy to install the mod if you use the Fuse Wabajack Auto Mod Installer. If you just Google that, you will hopefully be able to get it running in like 2 hours, something like that. It completely installs an entire virtual reality mod list for Skyrim VR. So if you have Skyrim on your computer and you have a VR headset and you have a Muse device, just go ahead, Google Fuse Wabajack and install that, and 2 hours later you can play with the Real Virtual Magic mod. It's really that easy. I have like 10-15 testers now on my Discord, so a bunch of people already used it and played around with it, and I'm always very happy to see more people there, and also get feedback on, obviously, on how it works. But going a little further from here, this is really just the beginning. I definitely want to continue and improve this. So I'm currently working on an overhaul of the processing. I'm creating a little external app, the Z Suite, Xander Labs suite, where you can see the real-time data. You can select a bunch of different parameters. That's the same parameters you can currently select in the Real Virtual Magic mod ini file. And then you can see all that in real time and it's much easier for you to also restart, for example, the EEG processing if the connection is lost without having to restart the game. And you can also just see the data, which is cool, I think. And so that's going on behind the scenes currently. It's going to be released sometime soon. It's not done yet, but it's definitely still definitely being worked on. And the mod itself is obviously also getting improved. So the usability currently is limited, and the impact on the game is also limited. But I really want to have this a polished version of cool thing that people can experience. So this is really my baby that I want to have in the world, where people can have awesome magical experiences in Skyrim. But that's not all, right? So going further, going beyond Skyrim, I am creating a Unity plugin. So this is not there yet. Just to be clear here, this isn't here, but I want to create it. This is going to be created in the next months. Hopefully by the end of the year, I will be able to share this Unity plugin together with the Z Suite. And that means that any Unity game developer can put this into their game if they want to. So this is really what I want to do. I have this community, and I want to grow this community. And if you are there, you will get behind the scenes knowledge, and you will have access to the Z Suite and the Unity plugin as soon as I have it ready. And then yeah, let's do this together. I really want this to be a community thing. I want everyone to be everyone who wants to be involved in creating awesome VR BCI games. So join the Discord. And now a little bit about the future. Just a little vision that is probably clear to everyone here in the neurotech community, but it's always nice to hear it again, in my opinion. So I cannot stress enough how important I think physiological data is going to be in the next years. I think it's going to be essential. Really, any major company is going for that. In virtual reality, eye tracking is going to be abundant, so it's going to be a non-issue in 2 or 3 years, maybe 4, in the very, very stretched, distant future. But really, I think eye tracking is clearly going to be part of virtual reality. And then we have heart rate. That's also very easy to add. And then we have projects like the OpenBCI Galia, which is fantastic, a made for VR physiological interface device. And I hear an echo now myself, sorry. So yeah, the Galia is great. It's probably going to be more costly than the Muse, but still, like, the future is going to have that. It's going to include that. And then we have Meta. You probably know that Meta has bought Control Labs a while back, and they're doing the physiological interface stuff for their AR, VR vision. And everyone's on board, right? You have other companies. Just a few days ago, the Snap company, has bought NextMind, if I am correctly informed. So really, the companies are going for it, and that is really cool on one hand, but it's also a little scary because they have a lot of power if they have that, like privacy. Meta is not exactly known for privacy. If you imagine a company like Meta with their Oculus devices, they have access to literally everything about you, right? They can read the user state at all times. They can know exactly what's happening around the user at all times while you're in VR. And if there's eye tracking, they even know what the user looked at. And then knowing all these physiological responses and all the things that you looked at and the things you interacted with, that's an incredibly powerful data set. And it's really important that we have a close look at that, and that companies are regulated on this and what they can do and what they cannot do. In my opinion, that's really, really important. Otherwise, we won't even realize when things are too late. But it's not only grim, right? So let's assume that everything works well. There's the potential of virtual reality brain-computer interfaces is incredible. It's beyond what we can possibly imagine currently, I think. So if we're just going crazy with our thoughts, we can have completely adaptive virtual worlds. Like you are in a world and that world adapts to you continuously, not like whenever you look at stuff, whatever happens in your body and in your mind and in your environment, everything is known and fits just right for you. So you can have visuals, you can have sounds, haptics, everything is just right for you. The world can, like, one day you feel like sad, one day you feel very happy, and the world just knows that and it adapts to what you need right now and what you want, even without you knowing. And that's really the important part. Like, this adaptive stuff can happen without you consciously deciding for it. It just has an intimate feeling for you, and it knows what you need and how you want to interact with the world. And this interaction, I mean, real virtual magic is a Skyrim mod. That's it's cool. I mean, I'm super happy that it's there now, and I'm very proud of it. But it's tiny Skyrim mod, right? So this kind of interaction using physiological devices is going to give us powers that we cannot yet imagine. And I mean, literally, we cannot imagine that because the tech is not there yet. Right now, the tech is very limited, but it won't be in 10 years, in 50 years, in 100 years. This neurotechnology is going to change the way we interact with everything entirely. And in the end, we have AI, intelligences like virtual agents that look at you, that adapt to you, that grow with you. Maybe like you have your body, your VR BCI body that grows with you since you get the device. Maybe you can even take it with you from one device to the next one, and so on. So this virtual agent might have a direct knowledge about what you like and what you don't like, who you are, and so on. And all the privacy risks aside that I have already mentioned, this could be incredible for us. This could be something, yeah, just beyond what we can experience today in any shape or form. So with that being said, the future is going to be dank. This is an older meme, but it still checks out in my opinion. That's me and the boys in VR with BCI technology, neurotechnology, and I'm really looking forward to having that. And with that being said, let's stay in touch. I'm obviously we can have questions and discussions now. You can find me literally everywhere. Discord. I prefer Discord. I'm basically living in Discord. You can find me on Twitter, on LinkedIn, Reddit. I have a YouTube channel about Skyrim VR mods, and you can also email me here in this email displayed. Okay. So that is the end of my talk. I thank you for your attention. I hope you liked it. And yeah, questions?
Yeah.
Comments?
Woo. Yeah, so for questions and comments, since he currently can't hear you guys directly, just tell me the questions and I'll ask him. Yeah, so are there any questions about this stuff right now? Yeah.
Could you increase the screen size of the video camera on the YouTube feed
Oh,
so I can
yeah.
see you guys?
Yep, wait just a sec. Yeah. Yeah, I only have small camera right now, but Yeah, so what's your question?
Yeah, I was just wondering in general what it took to interface with the Muse, like if there's open source architecture with it, or if it had to be reverse engineered. Just a little bit more in depth on what it took to interface with the Muse.
Yeah. So the question was, how hard was it to interface with the Muse? Is there any open source packages, or did you have to reverse engineer any stuff to get the Muse to work with what you built?
That was actually very easy. As I said, I use BrainFlow. BrainFlow is an open source MIT license, so do whatever you want licensed software package, and you can get it on Git. Basically, you can also install it with Python and so on. So it's really easy to work with. And BrainFlow supports different languages: C++, C Sharp, Python, even MATLAB. It's incredibly powerful to interface with stuff, and it has the Bluetooth interfacing with the Muse integrated. So really, it was that easy. I just told BrainFlow to connect with the Muse, and it worked. The only critical points here are that you need to have a Bluetooth dongle that is powerful, and it should be close to the Muse. So anything beyond 1 meters is not going to work well. So you have to plug in a dongle into the VR headset, or you have to plug in the dongle into a USB extension cord, and then have that close to your VR. But really, the coding for interfacing with the Muse is incredibly easy using BrainFlow. Otherwise, it's incredibly difficult, but luckily, Andre has solved that for us.
Yeah, I want to mention actually that Andre is going to be speaking later tonight about BrainFlow, about the tool he just talked about. It's going to be pretty in depth. He's going to be showing some of the code and stuff. But yeah, stick around or come back. His talk is from 10 p.m. to 11 p.m. tonight. Yeah, so if you want to learn about BrainFlow, definitely come by to that talk.
I hope it's recorded because I really want to see it, but I'll be fast asleep that time.
Yep, yep, yeah. Are there any other questions? Yeah, okay. Yeah, so one of our people here who I know pretty well, he just pulled out his Muse and is installing Skyrim VR to get it working right now. Yeah, Alex, what
Nice.
was your question? He just said he's going to go to Hogwarts and do spells. So, yeah.
That's going to be in the future
Yeah.
version.
Yeah. So he wanted to know what Discord he can talk to you in. I mean, I know you're now in the NeuroTech one, but you have your own
Yeah.
Discord, correct?
Yes, that's correct. You can talk to me in the NeuroTech Discord, and you can talk to me in the Discord that is displayed here.
Yeah.
So that's my real virtual magic Discord, and I'm really approachable on Discord. So if you ping me or send me a message, if you have trouble installing and so on, that's I can help you out with that, or the community can do.
Yeah. Yeah. So his question was how to get the Muse to talk to the computer instead of the phone. I think it's the Bluetooth dongle issue you were mentioning earlier, which I know a lot of people with Muses who've had that same exact issue because laptop chipsets for Bluetooth are generally garbage unless they're a Mac.
Yeah, that's correct. So you have to switch off your Bluetooth on your phone. If you have Bluetooth on your phone switched on and you have the Bluetooth, the Muse app on your phone, it will always just hijack the Muse as soon as it's available. So you have to make sure that that's switched off, and then it should work. Yeah, but it is true. Notebook Bluetooth connectors are generally garbage, and I recommend having a separate dongle for that.
Yep. Okay, so okay, cool. Another question? Yeah. 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 Yeah, so the question was about brain load. He mentioned that when you were burning then PCs, he saw that you mentioned brain load, and we're wondering if there's certain activities that you've found in your research that cause a change in brain load. I don't know if yeah, or if you've been gathering data in general about it.
Yeah, so currently the processing is rather limited, and normally, so in my research, I put a lot of emphasis. That's actually my entire PhD is about how to remove artifacts from the EEG data. So with high density EEG, you have options to remove eye blinks and movement and so on. So that's really powerful. Sadly, you don't have that with the Muse with only 4 channels. So currently, the brain power value is definitely affected by artifacts. So if you use muscle power and or you blink your eyes, then the value will be dropped. Um, Luckily, this coincides with the inner feeling of being not focused, right? So if you move your head a lot and you look around like a maniac, or you blink a lot, then that means that you are not focused. Also, it feels like that from the gamer's perspective. So that is something that affects the value. And then I I try to focus on my breath, and or to focus on the thing I look at, like really, really look at it. Um, I I want this to be more directly classified. Currently, it is not. There is no classifier doing that in detail, but this will be part of the future versions, especially with the Z Suite coming along now. I will improve the functionality and include different classifiers there that can also be part of the game. So the game can have different classification, training sessions, and so on. And then these training sessions will be the thing that you measure, right? So then you can decide what you measure. But I think so. The values that I currently use in the RVM mod, they focus on relaxation. So if you can calm your mind, your brain power will be higher in the game.
Okay, down in front. Uh, okay. Yeah, so the question was about how many hours of data does it usually require for the inner focus and for the overall JIT using the system, I'm guessing, as well.
It should be working fine just when you start the game. So the data is lost whenever you restart the game. Also, I should mention that, or I should have mentioned that everything is processed locally. So that means nothing ever leaves your computer without your consent. It's possible to record data, and then you have your own data file that you can share if you want. but that's really it. So that means whenever you restart the game, everything is started from scratch, and there is some internal calibration going on to the current user session, and that is all going on behind the scenes. So the user ideally shouldn't really notice that too much. So obviously, in the beginning, it's going to be a little bit more. There's going to be more variance in the brain power value because the calibration isn't fully functional yet. But really, you start the game, you run around for a minute, and afterwards it should work. And that's also the experiences I've got from the people who have tested it. It seemed to work very well for them.
Thanks. Okay, next question in the back. So the question was, what low-cost brain-computer interface, like EEG headset, would you recommend to buy if someone just wants to play with it or do lightweight dev on it?
Honestly, the Muse is great. The Muse S is better than the Muse 2, and it's the cheapest you can get with legit data. So it has 4 channels EEG. It has a heart rate sensor, and it has a gyro and accelerometer. It's really data rich, and you can interface it nicely with BrainFlow. It only has 4 channels, so it doesn't have channels on the top of the head and also not on the back. Certain things will not work well. So if you want to do motor imagery, the Muse is not going to be a good choice here. So you need something on the top of the head. And more channels is always better. I have made good experiences with the Muse. Other than that, OpenBCI is always a good choice. And I don't have one yet, but I have heard and read very good things about the Neurosity Crown, which is, I think, 8 channels EEG device on the center and back of the head. And it also interfaces with BrainFlow. It also interfaces with Lab Streaming Layer, which is the protocol we use in our research. So yeah, whenever I have my hands on that, I can tell you more, but this seems to be a very good device too. So depending on what you want to do and what's your budget, I think the Muse or the Neurosity Crown are good choices. And if you want to be more flexible, then the OpenBCI stuff is probably the best option.
Thank you very much. Do we have any? Okay, here in the middle. Yeah. Yeah. So the question was about physically passive BCIs and the um, use cases of those in the future, and what do you see being the use cases for passive BCIs in these situations, if I got that kind of correct? Yeah.
That's a very good question. It's actually a really important question because without a good use case, the hardware will not take off, right? So I'm open to take to have the discussions about that. Any good idea is good, and sharing them is also very important and good. What I envision There are a bunch of things that can be done right now already. So, for example, workload detection works very well. There is a complete field of neuroergonomics, which does a lot of that. There are even people doing that on real pilots in actual airplanes, using EEG or FNIRS devices doing that. So this is something that I can see in the future with better tech and better algorithms. I can also see things like error monitoring. So if you're doing stuff and things happen that you don't expect, or you make mistakes, there are certain brain signatures that are distinct for these two cases that we can also measure. And that is, so I genuinely think BCI as a widespread consumer technology will only be a thing using virtual reality, because like without VR, so either that or the devices have to be extremely easy to use and good looking and like when you walk around with them. But in VR, you already have something on your head. The threshold to add a device on your head is very low. And in VR, as I said, you have access to everything. So you have an eye tracker, you have the virtual world that you can change. And here I can envision much more. Like it's incredibly powerful what you can do in VR. I mean, you have seen this game or like the experiment, my neuroscience experiment with these yellow and blue blobs that float towards the participant. And here you can see you can imagine the whole thing being completely hands-free, right? So just by looking at the blobs, we might be able to tell whether the participant sees them as a target or as a non-target. And then we can change the color, indicating that we want to pop the targets without the user touching them. And then on that color change, we know, this was a mistake, because the user directly gives that feedback via his like brain signals, and then we can either pop the bubble or not pop it. So that could work really hands-free, and these are only proof of principles, right? This is a neuroscience experiment in university, but you can really imagine that things like that, like if you walk through a virtual world, and this virtual world does stuff, and whatever happens in that virtual world, it knows exactly if you like that or not, and if this fits in your current cognition or in your model of the world, or if it doesn't. And then for games, that's there are so many things that you could do. You can have, for example, games where you are a sniper and you can only shoot, or you do much more damage when you shoot between two heartbeats. We can measure that, things like that. And if you shoot and you miss, time turns backwards 10 seconds, stuff like that. And not because you missed the target, but because you assessed, you, the person, are unhappy with what happened. We can measure these signals in the brain. So I think there are many different options in games. And then if we're going to the healthcare sector, there's much more here, right? I mean, we can all these anti-stress applications. The Muse itself is such a device. These are pretty trendy at the moment, and I think they will be in the future. And connecting that with an engaging virtual reality game, I can see a lot of users not using meditation devices, but instead playing a meditation game, or a game like this Real Virtual Magic mod Skyrim, because it's fun, and they still train the same skill, even though they don't think that they are meditating, but they still do, kind of, right? So here I can see like applications in the healthcare sector, also, for example, high performance enhancement stuff, like learning to focus while you are under stress is really a key skill that that I can see being practiced with BCI. So the YouTube stream is stopped now. Is that correct?
Yeah,
Yeah.
I just saw that there's a issue with the YouTube stream. Yeah, I'm just checking what's going on. Um, yeah, because it looks like it should still be live, but something's causing a lot of dropped frames I just noticed. So, um, yeah, wait just a sec. Um, yeah.
It's already 5 past. I think I don't want to take too much time from the following speaker, right?
Yep. Yeah. So, it looks like it started back up. Okay.
Okay.
Yeah. Yeah. Thank you so much for your talk. Yeah, I'm going to. Yeah, people can get in touch via the link there, or later on tonight, I'll talk a bit about NeuroTech X SF and the NeuroTech X community, which is another group that people can join. Um, but yeah, thank you so much for your presentation.
Thank you very much for having me. It's great to know that people are interested in it, and thank you for your questions. This is really good, and especially the question about use cases. Please let us discuss. I would love to hear your thoughts. Let's chat. Not now. I will go to bed now, but I will read everything you ask you're discussing tomorrow, and I will answer to it, and then let's just continue with this whole vision, right?
Yep. Thank you. Oh,
Thank you.
uh,
Goodbye. Have fun.
see ya. Yeah. Okay. Show all participants. Okay, cool. So the next person speaking is going to be Eli. He's going to be speaking on his game jams he's done, which are BCI game jams. And uh, let's see, can you unmute yourself, Eli? And can you hear us?
Yep, I can hear you fine. Can you hear me?
Yep, we can hear you. If you want to start presenting, go ahead. I'll open the stream. Cool.
Perfect.
Yep.
Let me know you can see it just fine.
Yes, we can see it. It is working good.
Great.
Um, yeah.
All
Cool.
right. Well,
Go
thanks,
ahead.
Brian. Yeah. Thanks for inviting me to chat and letting me to talk with you guys about accessibility and design and a postmortem on one of the events that we run called the BCI Game Jams. And so my name's Eli Kinney Lang. I'm the lead research scientist for the BCI for Kids program. So that's my day job, where I get to hang out with some of the cool kids that you see here in this photo from our 2021 Game Jam. And then I'm also the founder of BCI Games, in which we are working towards improving accessibility and game design, thinking about how to make games more accessible for more people. So we'll touch on that a little bit. But to start with, um, I want to introduce you to one of our awesome BCI scientists. This is Daniel, and he is a kid who's been in our program at the BCI for Kids Lab at the University of Calgary for the past couple of years. Dan is a great representation of why BCI really matters for children and what opportunities there are in sort of focusing on BCI for kids. So Dan loves playing games. He's a big Pokemon fan, and he is really excited to be able to interact with the world through BCI, because Dan has quadriplegic cerebral palsy, which means that he effectively cannot use his body. He is also nonverbal, so the majority of the way for him to interact with the world is through access technologies. And really, part of what we've done is tried to position BCI as an access technology for Dan to be able to build a wide variety of applications or different ways for him to interact with the world around him. And so Dan is a great example of kids and why we care about kids with BCI, because they're an ideal population for long-term use of these technologies. In particular, using BCI systems with kids can help tap into the neuroplasticity that exists there, as their brains are still capable of quite significant changes. And this is something that is incredibly important as they're learning to use these different access technologies and for learning different skills as they continue to grow and develop. And additionally, why we care about pediatric BCI, and this will lead into why we do the BCI game jams, is because improvements for BCI for kids actually help all BCI users. And I'm just going to dive into that last bit really quick for you guys, um, and why BCI for kids is the next generation of BCI users. So, how these advancements really benefit is some of the challenges that you end up seeing in BCI can really be thought of as really good benefits if they're tackled for everyone. So, for kids, there's a lot of difficulty in recording the data from them. There's a lot of noise. They have headrests, as you saw in the photo of Dan there. There's a lot of movement due to boredom, etc. But if we can tackle some of those challenges, we can actually improve things like the signal processing pipelines, the machine learning going on, the headset design itself, how to improve artifact removal that could benefit everybody, not just kids who use BCI. Similarly, kids are very varied in development. So a 6-year-old and a 16-year-old are very different. And trying to tackle and understand how to adapt BCI systems for them can lead to promoting greater BCI generalization, making it easier for you to pick up a system and just use it right away. Furthermore, things like task complexity, again, trying to think about the age range of developing an application for someone to use BCI is quite different if they're 6 and maybe just starting to understand things like literacy versus if they're 18 and they've been reading for quite a long time. And that lets us think about how to design more intuitive BCI tasks. And then ultimately, right now, a lot of BCI applications are just built for adults. They are built as experiments, as the last presenter showed and highlighted. But focusing on adults there means that we miss out on some of the play and the enjoyment that you can get. And if we start building more for kids, that's the things they're interested in because they learn through play, which is really quite important. And some of these benefits are actually already happening within the BCI community. So emotive headset have started to be designed to change position so that they can account for things like headrests in the back of the head. Wearable sensing is another group that has started to look at creating smaller versions of their headset and adapting those to have less channels and less setup time so they can work with young kids. And then there's groups like ourselves at BCI Games and others like Brains at Play and even the NeuroTechX community who are starting to look at BCI from a play and enjoyment standpoint. And so very briefly about BCI Games, kind of what we're all about and what we do. We look to design for developers, but build for everybody. So when I'm saying design for developers, really trying to get developers and game developers and those out there in the field to improve their thoughts about game design and development from an accessibility point of view. Lately, a lot of that has taken the form of the BCI Game Jams, where we invite in families to come and talk to indie game developers, to those who are interested in getting into game development, to a wide variety of neuroscientists and other stakeholders interested in brain-computer interfaces, and get them to talk directly with kids who would be using these systems and using these games to play video games for the first time in their life. On the left here, you see this was a BCI Game Jam in 2019 when we were still in person. We held it at the University of Calgary, and I'll go into more depths of these along the way, versus last year's 2021 Game Jam, where we did most of it virtually, but the families still were able to come together and play and get to talk here. And I think it's really important to connect those two groups to be able to think about accessibility and how some game design elements are not super accessible when using BCI specifically. Um, and we try to help support that by building for everybody and create new experiences to kind of revolutionize iGaming for everyone, no matter their physical ability. And so we do that through things like our own games that we build just for fun, like Brain Joust, and outputs that we help support following BCI game jams. And this is all motivated by real end users. As we asked kids with complex needs who actively use BCI what they enjoy most with it, and the number one answer was playing games. BCIs can really enable them to play games with their friends for the first time, with their families for the first time, and individually and independently, which has been really quite powerful. And it's a brand new world of immersion for these kids. And really, that's something that we want to help support and support developing as many games to be BCI ready as possible. And we do that by aiding some in the sort of developmental toolbox and design concept there, from talking through kind of how to design games with BCI in mind, how to add BCI into games, and provide tools to support that. So one of the first tools that we had put out was the P300 dynamic plugin for Unity. For those who don't know what P300 is, it's a event-related potential. It's a visual evoked potential. It's something that happens as you're staring at the screen. I'll show you an example here in a minute. And the idea is that it's a very stable neural signal that you can use to control a system using visuals. And our goal here was to create an easy to include asset for the Unity game engine that utilizes this P300 visual stimulus as the primary BCI input control scheme. So this is going to flash on the right here. And so if you're staring at that middle cube, every time it flashes, your brain says, oh, hey, that was super interesting. Something changed. And we can actually pick up and figure out that that was the cube that you were looking at for you to be able to control a system. We made this to be dynamic so that you can change object properties, arrangement, color, presentation, row column flashing, single column flashing, etc. And the main other primary goal was to take care of the back end BCI information there. So using things like lab streaming layer to send and receive the timestamps and inputs from an EEG device to Unity, leveraging things like EEG Lab and BCI Lab and Python now to handle the signal processing and actually get your classifiers to give an output there, to then classify and predict these in real time. All these codes for the P300 dynamic plugin are on GitHub under my name and the BCI Game Jam 2019. And the developer interface, I'm just going to highlight really quick. It was just an easy component that you can kind of plug in. Had a bunch of different exposed properties for you to be able to mess around with. So you can change things dynamically in the game, such as the distance between these objects, the number of rows, the colors, etc., to change that stimulation. And I'm just showing what this looks like. And these are just two really quick examples of little in-lab games that we did with the kids. So you can use it as an active game object. Here they're trying to find Mario characters that get flipped over, as one of our participants loves Mario. And then alternatively, you can also do UI control systems so that as things are selected, it actually interacts with the game world for you. But that essentially is being replaced. We are updating it, we're overhauling it with something called BCI Essentials in collaboration with BCI for Kids, which is an update to the P300 tool. It's in development right now with one of the excellent engineers at the BCI for Kids program, Brian Irvine. And we're looking to make a rapid implementation tool that doesn't just do this P300 visual system, but also SSVEP and motor imagery. And we actually have a pre-alpha available for that on GitHub right now at this address that you can see here. The warning being that, again, this is all very, very starting point, but we're using it for one of our great PhD trainees in the program, one of her studies, and we were able to put together, I think, 6 new applications pretty quickly. And that, by quickly, I mean in 2 days using this, which is great. So quick recap about us, and then we'll talk about the game jams. We're dedicated to building the systems that are needed to create good BCI games and to enable developers to build BCI games. We want to support developers so that BCI can be a new avenue for accessibility, especially for those living with complex needs. And then we want to help create new experiences for all players through BCI-enabled gaming, through tools like the P300 plugin and now the BCI Essentials. So, post-mortem about the BCI game jams. So that's a little bit of background, kind of where we're coming from, why we care about BCI for kids, and um, what we are about at BCI Games. So in 2019, we held the first BCI game jam in North America. This was 46 participants who joined from across North America. We had 2 primary sites, one in Calgary. This is a photo from that group in Calgary, and one in Edmonton, who is doing another in-person session. And really, it's a 48-hour competition. For those of you who've never done a game jam before, it's exactly the same idea. It's 48 hours where you have to build a game from scratch. But in this case, the theme is build a game that is BCI enabled from scratch. And we supported by providing those tools up front and accepted submissions that either were P300 driven or very simple driven single action, single button games, which we can adapt BCI systems to use. We got 9 games submitted, which was really exciting. They were built using the prototype of our dev tools. And all of the participants really enjoyed it. We had got great feedback from those who joined. We got great feedback from the families. And most importantly, the kids got 9 new games that they're still playing today that they are loving. And so this is just a look at some of those games. And I can break down some of the game elements. I'll go through them kind of one at a time. We have 9 games here and then 11 more games afterwards, but I'll talk through somewhat slowly, but I know there's going to be a whole talk on um, design elements later, so try not to step on too much there. So this first submission, Planet Defender, this is a P300 enabled game. You can tell by this big giant marker in the center here, which is going to be doing that flashing as a UI over the enemies. And so this is a great example of sort of integrating a P300 flashing scheme that can be BCI enabled and BCI controlled to really go into a virtual world. And so here you can see these enemies are going to be approaching slowly, and it's actually kind of turn-based in that you'll see the flashing occur, and then when flashing finishes, the enemies would then approach. So through this, I want to keep in mind here, sorry, it might be a little loud, that because this is a game jam game, as are everything here, these were built in 48 hours, and while we adapted them to some degree, we tried to keep them as original to the submission as possible because the kids were actually the judges for this event. So the kids weighed the judging by 70%, and then us as experts by 30%. So we tried to make sure to give it as functional to what was submitted as possible with the hope to expand these with support from the developers later. So this one was runner-up for the Game Jam in 2019, but was just really well made, had music, everything there. This is a submission called Color Kaze, which is really focused on painting. One of the girls in the program and a number of the boys quite love painting with their BCIs. And I want to show you the Game Jam submission version. So here you can see again, this is P300 flashing that's occurred. Spoiler alert, I love this part of it. This was their whole submission. No matter what you did, it always told you it failed, which was hilarious to me. But they did a really clever use of integrating that P300 system, again, those flashing lights, as well as a directionality and a power within a single block here. So you got a lot of control from what is essentially a pretty typical BCI paradigm. And then we sort of took that and adapted it some, made sure it didn't say you failed anymore, and helped develop out some of these levels a little bit more, so that you would have a bit more fun painting occur. This one has no music as a heads up. This is another example. So this is a submission called Kirby Pop. You can hear the beautiful music there, which I'm going to mute for the moment. I'm going to highlight just a couple of things as it comes up. So this, you can see, has pretty poor contrast in their P300 flashing up on the left, but it's again a different way to be able to aim and point and shoot this totally random character that has no copyright infringement, to try and eat a piece of cake there. And so editing through that, the nice thing here, we just wanted to make sure that it was a little bit easier to see for a lot of our kids who may have some form of color concerns. And so that contrast is much stronger. And again, higher contrast in this case helps support the ability to use this as a BCI system. This is actually Kirby Pop in action with Dan, which is quite exciting. And so he is using it right here, and he has already knocked over this here, and he is lining up his shot to be able to get that last piece of cake, which is exciting. This was the winning group. This is called Sumo Boodle. It is played often by our kids still. This was submission from a group in Toronto, and it is actually a multiplayer game that was single button multiplayer game. So 2 individuals sign in, and you can play up to 4 players. And then here you try and focus on an imagined action, such as pushing your arms forward that you trained the BCI system for, and try and focus on it to hit the other individual across the arena. This is Zap Attack, which again uses the single button system, the sort of imagined action system of BCI, to then have you do some hunting, where you are trying to wait until the duck is perfectly in the center there to be able to shoot him down. Pretty standard here. I like to show it off though. I love to include this one. This is Endless Runner, because this was the individual who had never done game design before, never done game development before, and he was really concerned about this whole event. And he put this together. He asked me what kind of game I thought would be great for BCI. I mentioned an Endless Runner in which you would have a slowdown zone just before an obstacle, so that you'd have plenty of time to be able to react to that obstacle and be able to effectively jump over it in this sort of Endless Runner. And he put this together with that in mind. And one of our children in the program got this game and loved the animation on it, the simplicity of it, so much that they played it, I think, 2.5 hours the first time, just straight. They loved playing this game. They thought it was super funny. And they just got a kick out of being able to jump over these obstacles themselves. And again, I really want to highlight how important it is for these kids to be able to play these games. This is the first time for many of them they've gotten to be able to. This is an example of a more complex game that was put together. This uses what's called switch scanning skills. So as you saw there was some flashing that occurs, and you'll see this happening on the bottom here. I don't know if you can see my mouse, of different objects that you need to select. So you have a laser gun, a missile, and a shield, all with their own cooldown, and they're going to be highlighted one at a time. And you need to activate the BCI system using an imagined action when it's over top the object that you would want to shoot. So that's flashing. It shoots out a little laser. Now it's the missile, and now the shield, and you have to wait until it goes. This is quite a difficult game, but our kids have gotten quite good at playing it, better than me playing keyboard and mouse, just because of how difficult it is sometimes to balance those cooldowns. I would love to show off this one. It was a storybook game, but it was submitted in Delphi, and my computer does not like to record Delphi. It's really hard. But here, again, they go through and highlight these different characters, and they tell a fun story about what this character does. It was targeted towards our younger participants in the group, which was excellent, and I really appreciated the dev who thought about making a game for the younger kids. They also we had some submissions that were non-traditional.
No,
This is a
the
group
Centaur was trapped in a
from
maze.
Edmonton who
Rory,
submitted
help get it out by
a
using
game
5 minutes
of
at a time.
moving a robot arm with a maze. Unfortunately, we didn't have access to the robot. This was a group up in Edmonton, so we never got to actually play this game with the BCI headsets, but I'm sure it would have worked because it was using one button at a time. So those were the submissions from the 2019 competition, which were all still quite a great range there. And we're going to move on to the BCI Game Jam 2021. Sorry, it's 2022 now, but the 2021 competition. So some quick facts. This happened in October. We run this pretty much yearly in the fall at some point because it takes a while for the kids to judge these games and give feedback so we can announce winners, which we'll be doing next week actually, which is quite exciting. This time we had over 100 registrants for this game jam. There were 67 participants who actually joined in and were active throughout the competition, and they were across 6 different countries. So we had participants from India, participants from South America, from North America, and a variety of other countries. The presentations were given similar to this one, as well as the family panel, and we found a really nice output was that a majority of those who participated found that they got increased knowledge about both game design, game development, game tools, and BCIs. We ended up with 13 game submissions. They were all multiplayer focused, and we had 6,000 Canadian worth of prizes for this competition, which we have been slowly giving out. And the winners, as judged by our kids, are going to be announced tomorrow. And most importantly, we doubled the number of BCI available games for our kids within the BCI for Kids program and other programs that we work in collaboration with in 48 hours, which was really exciting. So I'm going to go through some of these submissions as well, and just want to highlight a few more of the really excellent design ideas. And this theme, again, for this year was multiplayer madness. So all games had to have a multiplayer component to them. This was a game called Xiao, which is a single button game. It's competitive, and our kids loved the characters of the dragons in this, and being able to fight against the siblings and families. So I'm going to pause right here. The way the game works is as these symbols fall down, you have to imagine your BCI action or focus on your BCI skill to be able to collect the symbols that you want. If you get 3 fire symbols in a row, then you will shoot out fire. If you get 2 gloves in a row, you'll punch, and 2 shields in a row, you will get shielded. And really, this is quite a clever use of single input BCI system for quite a fun strategy game. And it was fun not just for the participants, but for their friends and their siblings to play with them and against them as well. Because there's a bit of strategy that you really have to think about of, should I get this one? Because you don't know what's coming next. And it's offered the same between both groups. So you'll see he gets the 3rd fire, shoots out. He gets the 2nd glove, and he shoots out. This is the group that won the 2019 one, came back with a new game called Suboodle. This is from the Holland View Kids Rehabilitation Hospital in Toronto and their partners Pearl Lab. And this is a P300 driven game that was collaborative. They didn't quite get to the multiplayer element, which is hard, but it was collaborative in trying to have you learn about where a variety of different educational environmental goals were, And really, our kids loved that it was relaxing. They've been, while watching, you can hear the nice music. They loved just relaxing to it, and you can see this is a great sort of tutorial of how to play, and that's a whole conversation to have of teaching people how to play your game. Um, and it was a nice educational game, relaxed music. It was a good way for them to practice kind of being calm and use the BCI system under a calm scenario. And so the character hides away, and then you have to focus on where it is. Um, this is brain space. This is another single button play, and it had joint play. So that's where one person will do asynchronous movements. In this case, move the spaceship up and down, and the other individual using the BCI will change the gun depending on what the object is coming towards them. Our kids have loved the theme of this and the feeling of control of changing those weapons in the right scenario so far. And really, this is a good example of clear instructions at the very beginning. It tells you exactly how the game is going to be played, and how a single button control can be used. So you can see, didn't quite switch it in time there. That time you did, so HP didn't go down. You switch back to this, switch it in time to go through. This is another submission focused on space theme. A lot of our kids love space theme. This is now what is called SSBEP, or Steady State Visual Evoked Potential. It's similar to P300, but it's a slightly different sort of visual external BCI stimulus. Our kids loved the music of this and again the theme of it. And this is just a nice classic remake of Asteroids, but reimagined with SSBEP as a control, especially for multiplayer. So I'm going to make this quiet. Here you can see they were using BrainFlow. I wanted to highlight that that was built into their setting menu, which was great. And so here you would have to focus on those flashing ships in order to shoot them. This one is Curl, which is about curling in space. This actually has some great music, but I am unable to share it for some reason. I don't know why. I was playing it earlier, but it was single button, 4-player, and it has both competitive and team play, as they included AI within the game, which is great. And our kids love that it's a sports theme, the ability to control a couple different things without having to do it repetitively, with having a break between the different sessions, which is really nice. And it's really just a great example of how you can use single buttons to play a pretty complex game and make that game accessible. So this is the first player. What they are doing, they have a shot that they have to line up, and then when they're ready, they will shoot it with their single button command. And then the second player does the actual brushing for this. And here, each time the imagined BCI action happens, it does another brush, which is great. This is a wonderfully imaginative game out of Southern California. We partnered with Brains at Play for this BCI Game Jam, and they had a in-person session down there at USC, run by Garrett Flynn. And this group came up with Sock Kitty, and our kids have loved the characters and animations in it. They've thought this art is so funny, and I just want to highlight how silly designs can work well and appeal to many kids. Um, it's a wonderfully silly game to try and explain to parents before they play it of what Sock Kitty is going to be about. And this is it. That's the whole game. You kick a soccer ball down a table, which is great. This submission did really well in coming through with the idea of an educational combination of kind of typical school activities of tug of war and mathematics. And our kids actually quite liked that educational side, because for many of them, they go to mixed integrated schools. And this is something where, again, they see their able-bodied and neurotypical peers doing these things, and they are able to join in and do some fun, exciting concepts through this. So this is a 2-button game where you solve math problems to try and pull your opponent across the line. So you have to imagine one of 2 different mental actions, so right hand or left hand, the imagined movement there, to select one or the other. This is a submission from a group in Montreal who did a great job with SSVP integration. It's a collaborative game, and they have done a really good job highlighting sort of what a family fun board game adventure could look like with, again, a visual evoked BCI. So you'll see me playing it here with a mouse, but it works. We had a girl come in last week and play this, and the kids have loved the dragon and the board game theme, and the fact that you get these fun various power-ups that you have to collect that they can play with their families. This is Rocket Mayhem. It's a single button game. It's competitive or collaborative depending on how you want to play, and the kids have enjoyed the colors in this game quite a bit. This is actually run off a web browser, which has made it very easy for us to play with families at home, because it is something that doesn't need to be downloaded. It can just play on any web browser and attach the BCI headset and get it to go. But it is very difficult, as you will see here in a minute as it moves up. The goal is to not hit those, but for anyone who's used a BCI headset, sometimes you have to remain still and noise will move you. Again, this is using imagined action, and so it can become quite complex. This submission does a great job, again, of utilizing a single button for more complex outputs. In this case, the kids have enjoyed the theme of this a lot, the characters, and again, playing against their siblings quite a bit. 2 little penguins having a snowball fight, always fun, always enjoyable. And you can see here, I'm just going to pause, that the first action, the first time that you invoke the BCI system, it actually sets the angle that you'll be shooting at, and then the next time that you activate it or from there it will grow to the power that you want to throw this snowball at, and it will in fact then shoot afterwards. So you want to try and perfectly time both angle and power to hit the other person or get the power-ups in the middle. So lots of strategy, lots to learn here, and really a great example of long-term adoption. This is Maze Madness with totally unknown characters, and our kids have loved these characters. Again, we have some boys in the program who quite love watching anything to do with Mario, and they've enjoyed the sort of race mechanic that came here. And so you'll see here a little bit of a different way to implement that single button movement, in which you have your characters here move, and then if an opening occurs, then that single button can then pass through and change kind of how you want to move. And then sort of the final one to talk about, this is Gravy Train. They used P300 here. And again, it was joint play. They ran out of time to some degree to be able to do multiplayer in one sense, but there are collectibles that go throughout the levels. So the parent or whoever is playing with the kid will click on the collectibles to pick them up as the gravy train passes by. And the kids have really enjoyed the feeling of getting the gravy train moving forward. And this is a good example of how games, as mentioned in the previous talk, can really help with practical practice. And so getting that feeling of movement while focusing on a specific directionality is actually super important, especially as we've started to work on things like power mobility with BCI and the BCI for Kids program. And I'm going to pause. You can see here, there's an example of an item that would be picked up in joint play. So with that, I'll sort of wrap up my 45 minutes and happy to answer questions. Just want to go through a bit of the postmortem of the games and design very lightly kind of what's going on. Big thank you to the sponsors and partners from the BCI Game Jam 2021, especially Campus Alberta Neuroscience, who was our platinum level sponsor to help make sure that this event was able to happen, um, as well as all our other sponsors, Neurosity, Emotive, Wearable Sensing, G-Tech, Red Iron Labs, and Data Drill, and all of our partners at Brains at Play, especially who helped organize and get the multiplayer theme going with us, Extra Life YYC, as well as want to thank the children, parents, and families who continue to give their time, energy, and input to make everything that we do both possible and worthwhile. Thanks to the other BCI Games founders, Dion Kelly, Erica Floriani, Kyle Summerfield, Eric Mitchell, and Matt Curavilla, as well as Todd Wilsey of Endless Era Gaming, Extra Life YYC, who helped run a lot of our technical streams and website discords, etc. there, as well as the BCI for Kids team down at the bottom, who are I work with in the day job. So happy to answer questions. Thanks.
Yeah, so just to let you know, they aren't able to, you won't be able to hear their questions, so I'm going to relay all the questions to you. Uh, uh, yeah, so, let's see. First up, so does anyone have any questions right now? Yeah. Yeah. Okay, so the question was, how do P300s work? Like, what is a P300 and how do you use a P300 when integrating it into an experience or a game?
Yeah, great. Thanks for the question. Um, I wasn't quite sure how familiar people would be, and so I cut out my this is what a BCI is in 90 seconds slide, so I apologize for that. Uh, but ultimately, what the P300, it stands for the positive 300 response, positive 300 millisecond response. Ultimately, what it is if you're paying attention to something, it's very important that there's an attention component here, and you're visually looking at it. And we'll go back really quickly. Um, but if you're paying attention to something and you're very focused on it, when that object changes, your brain has what's called the oddball response. So suddenly your brain says, "Whoa, what was that?" Because your brain is incredibly lazy. And as you're paying attention to the thing, it starts to be like, all right, nothing interesting is happening here. And so if you change it in size and shape and color, you can evoke this very consistent response about 300 milliseconds later um, in the brain. And so here you're seeing these just randomly flash. So if I'm using this system and I'm focusing, I think, okay, I want to move this train forward. I can focus on this square and it stays this color until it randomly flashes. And so you saw it randomly flashed there and there a couple more times. I don't know how laggy that might be for you, but you can actually time that action, that flash, and you can check your brain signals and you can say, hey, 300 milliseconds after that flash occurred, what was this channel doing in your EEG? And you can check all of the different EEG channels that you want to. But if you were focused on that object specifically, your brain has a very clear positive response 300 milliseconds afterwards, hence the name P300. And so what's really good about it, what's nice, and it's used for a number of things, is this is sort of the prototypical very, very stable BCI signal that's used for spelling, for communication, for navigation. And in a game world, it can be both a real world object or a user interface object, depending on how you want to integrate that. Because all you need to do is sync up the timing from when you flash it and what the EEG looks like to be able to determine what the individual was looking at. I hope that answers your question.
thank you very much. Yeah. Anyone else here have a question? Yeah. So I'll ask a question that's actually kind of related to that, and that is, what's the difference between SSVP and P300? Like,
Great.
I know the answer, but I think it might be helpful for some of the people here if they try to use this type of stuff, what they should use when creating a system.
Yep. Nope. That sounds great. So I'll put this out there, which is that P300 is what is called time locked. So your signal is coming from the onset of that flash, and you look in the temporal domain for 300 milliseconds later. Steady state visual evoked potentials, or SSVEP, are frequency locked, which means that you still have to visually stare at an object, very much the same as P300, but in this case, when you're staring at it, it's flashing at a given frequency, say 15 times a second. So when I hit play here, you'll see these are flashing very different frequencies. So, but they're a consistent frequency flashing. So I think this one's at 4 hertz or so, and that's at 8 hertz or so. Um, and your brain is amazing in how lazy it can be. And if you're staring at that frequency at 8 hertz and you're really focusing on it, um, eventually the back of your brain in your occipital lobe um, will sync up to whatever frequency you're staring at. So we then just have to check those channels on the back of your head to say, oh, cool, he was looking at the object that's 8 hertz, or he was looking at the object that was 15 hertz. And it will sync up there and just we pass that information back to the game to say, yeah, move to this square.
Yeah, thank you. Um, yeah, okay, we have another question. Yeah, so the question was about the which game? Frothic game? Oh, Rocket game, and what that there was a issue with it regarding timing and the headset, and they were wondering uh, if you could explain a bit more about that, if you know what the issue was and how maybe you solved it.
Yeah, so this goes into a longer talk, which I'm happy to chat with anybody sort of following up on these questions, or anyone has questions about game design for BCI in general. But ultimately, the issue comes in that there are certain game elements that we have kind of grown accustomed to as game players and as game designers that are not great fits for BCI, and especially BCI systems, because BCI systems have an inherent lag built into them, an inherent variability built into them. And I like to explain and talk to the developers at the game jams and others who I talk to that if you want to get a feeling for what it's like to play a game with a BCI system, in your code, program after you do a button hit to resolve that button hit randomly between 130 milliseconds to 700 milliseconds later, and also sometimes just don't hit that button. Like, and that's what it can be like to play a game with a BCI system, especially something that's a commercial system that is just using sort of imagined movements or imagined actions that may not have as much coverage of the sort of underlying neural areas. And so Rocket Mayhem, which is a great game, the problem is that the timing needed to get through the asteroids is very tight. And it's very, very tight to do it with a keyboard and mouse with instant feedback, let alone if you're trying to just move intentionally with a BCI system by thinking of moving your rocket. Because that's how the system works, but there's this built-in lag. So you might think, okay, now is the time, but then it doesn't process at the same rate each time. And so how to get around that is by adding in other sort of features like having slowdown zones that give you that time variability, like an endless runner, or spacing those out a bit more, or having the ability to change the speeds at which things are moving, so you can pair it with the individual using the system.
Thank you very much. Do we have any more questions? Yes, in the back. Yeah, sort of building off that a bit, is that a flaw with current technology, or is that inherent to PCIs? And sort of expanding on that a bit, do you believe that there is a future where physically impaired people can use BCI inputs, and that can be mapped onto games that are built for conventional mechanical inputs? Or will BCI games going forward be locked or best suited for bespoke applications geared solely towards those kinds of inputs? Yeah. Okay. Yeah, so the question was about whether things like the latency issues and stability issues of things like pressing a button, if those are hardware dependent or if those are just regular brain dependent, that such that when we create applications and games in the future, will we be able to map traditional games to have controls via BCI devices, or will we generally do bespoke applications that are designed around using BCI devices?
Yeah, great question. Um, and so I guess to answer your first part, it's a little bit of both. There are so many different BCI control schemes that you can do, that inherent lag sometimes is a built-in lag from you personally, right? So again, things like the P300 response has a minimum of a 300 millisecond time on it if you only did one flash or a couple of flashes. uh, there's a minimum of 300 milliseconds that you have to wait before that goes through. Similarly, though, you have to flash things a couple of times. So now you're looking at usually on average, P300 selections are somewhere in the neighborhood of 7 to 12 seconds, because you have to flash each object and really make sure the object you're choosing is correct. So that's both a real world like brain problem as well as a BCI design problem, and there's a built-in lag there. Things that are initiated from yourself a little bit easier, so things like motor imagery, so an imagined movement, imagining your arms and moving those can be picked up somewhat faster, although less reliably, but there is still a little bit of a lag at the moment. Um, if we're living in the world of non-implantable BCI, which for me and the group that I work with, we only really are interested in non-implantable BCIs. That lag is always going to be there, but that doesn't mean that we can't make good game design choices around that to be able to cover up some of that lag and make the feeling of the game still fluid to play. So there's plenty of game and game design options out there that could be real world applicable for BCI. You could play I love using Pokemon as an example. Pokemon is a menu navigation game. At its core, you're navigating menus, and Pokemon is an excellent choice for BCI systems because of that. Because there isn't this built-in high time pressure to do a thing. So that real world rapid response, you're going to struggle to play first person shooters probably for quite a long time, solely from a BCI, but it doesn't mean that you can't play games that are puzzle designed, that have this sort of built-in ways to mask some of that lag that occurs in BCI. I hope that answers your question.
Thank you very much. Yeah. Any more questions? Yeah. Okay. Over here. Yeah. 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 So the question was about sequencing and how easy is it to get sequences of like sensing such that you can do more complex actions in something like a turn-based game where you might like Pokemon only has a few options, but there's a lot of games that have a more complex options every turn, and it's yeah, so how can these devices or algorithms work with sequencing and detecting a very specific sequence of either flashes or um, frequencies to do complex selections?
Yeah, that's a great question, and I think I think the answer is we're still at the nascent start of BCI games and integration with BCI. So I had a great talk with the 2019 winner of Sumo Boodle, um, when he came for the 2021 Game Jam, about how right now I feel a lot like I think the developers in the 80s for video games feel, because they had all these constraints in the 80s of how to make a good video game in in that much more difficult style. They didn't have Unity and 100 different assets and so much memory that they could do whatever they wanted with. And so questions like that are open questions, I think. There are things to be explored. There's ways, how do we make a game sequence useful and effective for BCI control or for accessible control in general? How can we integrate it for things, not just BCI, but other access technologies too, like eye gaze? How can we integrate eye gaze with BCI simultaneously to give multiple actions? There are things in the BCI world where you can do multiple sort of mental actions simultaneously, but you start to become it starts to become challenging to separate and decode those. But that's a bit of a longer conversation, I think. Um, but there is that ability, but it's mentally fatiguing. So if you're trying to imagine moving your right and left hand while doing mental arithmetic, your attention can only be placed in so many places. So it's an open question.
Thank you. Oh, yep. Here's another question. Yeah. Yeah, so the question, I might know the answer, but the question was earlier you showed a plugin with Unity to handle BCI devices. What plugin was that?
So this was well, I'll emphasize our updated plugin. So the one before, sorry, I'm just going through all the slides backwards. It was called the P300 plugin, exactly what you think it is. Um, It is on my GitHub at ekinney-lang and BCI Game Jam 2019. If you look at GitHub, BCI Game Jam 2019, you'll find it there. But ultimately, that plugin sort of handled the lab streaming layer connection between Unity and MATLAB, but it was specifically with MATLAB at the time. And we started to update it to Python so that we could do things more flexibly and enjoy that a little bit more. So that old source code used a MATLAB with EEG Lab and BCI Lab, and there are examples in it. But we do have a pre-alpha available of BCI Essentials at this GitHub down here at the bottom. And I'd recommend, if you have any interest in testing this out with us, feel free to reach out to me, and I can talk with Brian Irvine as we are developing this still, and be happy to get other people's feedback on using it. Right now, the way this works is it's a Unity plugin. It's just a couple of components that you add to your game, and it handles the stimulus presentation considerations and concepts at the moment. We have Python backend scripts that we're still working on, and we will work to make those publicly acceptable, is how I'll put it. But we're getting towards it. So follow us, reach out to me, send an email, and can keep you updated. We do have a BCI Games Discord. I probably should have highlighted that. And I'll release information on there, but I'll also release stuff on Twitter. So sounds great. Just being cognizant of time, though, I don't want to take up too much time from other speakers.
Yeah, that's fine. Like, after this, we have a music set until the next speaker. So thank you so much for joining us for that. Yep. Yeah. So now, before the next speaker, we're going to have a bit of a music performance by a member of the community here. And then at 10 o'clock, we are going to have our speaker from BrainFlow, who's going to be speaking about BrainFlow in depth and how to use it. I also might speak a bit later with a general large overview of the BCI space and different ways that that stuff can be incorporated into video games. But yeah, for now, I'd like to invite Mana up on stage for his music performance. And also, for people who've gotten here later, we do have some pizzas that anyone can have. Yeah, so it's going to be a couple minutes to do this. If you want to look around the space, there's a few people around space who can give tours. I think there's a few people doing playtesting upstairs right now. But yeah.
Great. Well, thanks so much. Good luck, everyone. Take care.
Thank you. Bye. Yeah. Yeah. Oh, I will. I just want to let Mana set up and let people explore some. Okay, so I need to change some audio stuff here. Yeah. So this goes into the headphones, or I mean into the, yeah.
Is that related to the valve index?
Yeah, so it's probably going to not be the valve index 2. Um,
anniversary.
Oh yeah, talk with Alex.
Alex said to connect with the guy, the Hacknight guy.
Oh yeah.
Put you on the list, so I'll come.
Yeah. Hey! Yeah. So I was so busy I didn't have time to run out and get any, and so there isn't any right now. But if you want any good recommendations, go with someone to Sycamore. Sycamore has Oh, okay. Oh, you need cocktails and stuff. Oh. Yeah, I don't think we have anything anymore. Since we don't have a new Larva, we can't serve per ticker right now. It's annoying, yeah. Yeah, I'm not sure. I need to keep working on this stuff right now, but yeah.
I just wanted to ask if there was any.
Oh yeah. Oh yeah. You'll have to ask Mark about that. I'm not sure. I only have one. I was thinking about getting some more made. I did need the logo. Because, yeah. But I know, like, a lot of people who wanted them weren't able to get them, so we should make some more. Yeah. So, I'd ask Mark. I am not sure.
I will ask.
Hello.
Okay.
Yeah, wait just a sec. I need to switch the audio for a sec. Yeah. Okay. Yep. Cool. Yeah. So. Yeah. Nope.
Yeah, I hear you. Yeah, yeah, I also. Yeah, yeah, no problem. Yeah, no problem. Got it.
Okay. Okay, good. Full screen. Oop. Yeah. Woo! Thank you. Yeah.
Thank you so much for
Woo!
having me. More talks. Woohoo! Let's go.
Yep. Yeah.
This was fun. I was thinking about trying to use my brain to control this after all this talk.
Yeah. Cool. Okay. Yeah. Whew. Yep. Okay, so we're about ready to one more talk. I might afterwards. I'm not sure, but okay. Who? Who? Full screen. Transition. Oh. Who? Yeah. Oop. Yeah. Okay. Yeah, wait just a sec. Can you try to speak? I need to check the audio. Yeah. Okay, so I think audio's working. Let me turn it back up a bit. Um, yeah. So let's do this. Let's fix this. Yeah. Yeah. Okay, can you speak again?
Yeah, sure. Do you hear me now?
Yep, we can all hear you. Sounds good. Audio is working. You can start your presentation.
Cool. I don't see you, but okay, that's
Ooh.
expected. So let's start, and probably I need to share the screen.
Yep.
Do you see
Okay.
my screen now?
Yep. Okay.
Cool. Do you see the presentation? Do you see the presentation?
Yes, we do. Yes, we
Cool.
do.
Let's start. My name is Andrei, and I am the creator of BrainFlow, and this presentation will be about BrainFlow overview and how it can be used in games and how it's actually used in games right now. And agenda for this talk is introduction. I suppose some of you already familiar with BrainFlow, used it, heard something about it, but I think some of you have not used it. So I will talk a little about history of the project, its goals, key features, and so on. There will be some live coding with mostly copy pasting of docs and other stuff for different programming languages and so on. And there will be a section about how it can be used in games. And also one note, if you have any questions, actually feel free to ask them as soon as you have them. There's no need to wait until the end of the presentation, especially since it's quite long and technical. So feel free to interrupt me if something is unclear. That's totally fine. And let's start with the introduction. I think I started to work on BrainFlow like 4 years ago, 3 years ago, something like that. And it is a library or SDK to work with different biosensors. Primary focus is near interfaces like EEG, EMG recording devices, and so on. But technically, it can work fine with any time series with any stream of data. And there are a few links. Let's go through them. The first one is Brainflow website. Here, the most useful link is Slack. Here, you can join Brainflow Slack workspace. There are like 600 members as of right now, so feel free to join. It's the best place to ask questions about this project and so on. There is blog post, the gallery page with some applications listed, built on top of Brainflow, and so on. Feel free to check that site when you have time. And another link is Brainflow docs. Here you can check all currently supported devices from different companies, installation instructions, user API, that's mostly after generated, code samples, data format, integration with game engines. We will talk more about it later on. And Brainflow dev section is mostly for Brainflow developers, for those who are willing to contribute to Brainflow with code. Check this page as well. GitHub. There are a lot of forks of Brainflow, but this repo is the official one and the main one. Use only that. Do not use forks from other companies. Feel free to check issues and tasks. Maybe you are willing to contribute with the code, start the repo, and so on. And link to Open Collective. Yeah, and let's start with the history. As I said, it's like 4 years old project. At the beginning, I bought a headset from OpenBCI. It was Titan. I had no plans to build something like Brainflow. I just wanted to get some data, train some classifiers, and do some fun stuff without anything specific, I would say. But when I bought it, I realized that SDK provided by OpenBCI was not good. And later on, I realized that it is a problem not only for OpenBCI, I would say. So there are different devices from different companies. They all use different communication protocols, different interfaces. For example, OpenBCI Titan uses serial port, in fact. On PC side, you work with the serial port connection. For use, you are working with BLE. For some of them, you are working with TCP/IP, and so on. SDKs provided by companies, if they are provided, actually, some companies do not provide them at all. For example, Muse deprecated their own SDK, and now there are only community projects like Muse LSL and so on. But quite often, these SDKs work on different operation systems. They support different programming languages and so on. As a user, you may want to switch between different devices, and you want to make that really simple, I would say. It should not be a big challenge for you to switch from OpenBCI Titan to, I don't know, OpenBCI Ganglia in order to use or to BrainBeat. But because of that issues, it was quite challenging. And as a developer, actually, when you develop your own applications, you want to target as many users as possible. And to target as many users as possible, you need to support as many devices as possible. And all of that was really complicated. It slowed down development, research, and adoption, I would say. And it was like one of the main issues I'm trying to solve with Brainflow. There are different attempts to solve that issue using streamers. For example, using something like OSC stream. So the idea of this approach is that okay, we cannot create uniform data format streamed directly from device, but we can create an application, run that on PC, and this application may convert stream from device to OSC stream, roughly speaking. And I need to confess that partially it does the job. So there are cases where it's great and makes a lot of sense to use something like that. But there are certain limitations. For example, you cannot send commands back to device. You need to run intermediate application and so on. And if you take a look at this issue from the point of view of device developer, you created new board, and you need an SDK to work with that. Even if you think that your end users will work only with OSS stream, you still need to develop an application which will convert one stream to OSC, for example, or to LSL. And if you're doing that from the scratch, it will be pretty challenging for you to create such an application. And also later on, you may decide that you need another app or something like that, and you will end up that you need an SDK, even if your end users will use different streamers. So Brainflow tries to solve that problem. It provides a uniform SDK for different devices with a uniform API, and at least as much uniform as possible, I would say. And let's talk a little about key features. The main one is distributed under MIT license. All parts of BrainFlow are completely open sourced. They all have MIT license unless there are third-party dependencies from the companies. They may have different license, but BrainFlow itself is distributed under MIT, and it means that it doesn't matter if you are a student, a company, if you are working on open source application or on paid closed source app, you can use BrainFlow. There are certain disadvantages in that. For example, it's hard to get paid for a completely open source project, and for example, some companies they forked BrainFlow to the private wrappers, integrated their own boards, and do not send pull requests to upstream. That totally fine. It does not violate the license, but I would recommend them to actually send a pull request to upstream. It should be quite beneficial for them, mostly. Uniform API for all boards. As I said at previous slide, without uniform API, it's very difficult to switch between different devices and develop device agnostic applications. So it is one of the key features of BrainFlow API is as uniform as possible. Of course, if you are training machine learning classifiers on raw data, it's almost impossible, I would say, to make it really uniform for all ports because they all have different separate rates, different number of channels, and so on. And you need to train classifiers for each case. But API about getting data from the board, signal filtering, and so on, that all can and should be uniform, in my opinion. Currently, it supports more than 40 devices from different companies like OpenBCI, Antnero, Neurosity, Unicorn, and many more. Check the website for the full list. There's also signal processing API. So in BrainFlow, there are multiple parts. The first part was data acquisition API. This part gets data from the board or sends commands to the board. And there's also signal processing API. It was added later on. The main idea of signal processing API is to don't try to pretend to compete with advanced MATLAB packages or with MNE Python. They are great, they exist, and there are like novel, cool algorithms for signal processing. But for example, if you are working on game development like in Unity, more likely you are using C# for scripting because it's actually the main and almost the only scripting language in Unity. And you will need to do signal processing in C# more likely, unless you create inter-process communication and move that to another app. And in C#, at least I do not know cool libraries for EEG signal analysis. And the same is true for other programming languages. In MATLAB and Python, yes, there is Skype, there are MATLAB toolboxes and so on. But in something like Java, C#, C++, and so on, there are no like standard libraries for that. And in BrainFlow, we're trying to provide that. at least we're trying to provide some basic algorithms, common algorithms for filtering, downsampling, transforms like with LED, Fourier, and so on. Currently, it supports 8 programming languages. Actually, I would say it supports all popular programming languages except JavaScript. And API is uniform, more or less uniform between them. And there are plenty of features to speed up development. It's written by software engineers, I would say, not by researchers. And there are a lot of tricks to speed up development of applications and to speed up development of BrainFlow itself. There are emulators, synthetic boards, and so on, plenty of different features. Let's move on. Maybe any questions so far? Looks like no questions. A few words about architecture of BrainFlow. As I said before, we need to support different programming languages because we do not want to limit software engineers in terms of programming languages they can use. For example, for scientists, for researchers, they prefer something like Python, MATLAB, maybe Julia. For production quality applications, software engineers more likely will do that in languages like Java, C#, C++, and so on. For gaming, it also should be C++, maybe C#. And we need to cover all that cases without any limitations for software engineers developing applications on top of BrainFlow. And at the same time, we do not want to rewrite existing code from one language to another because it would be unmaintainable at all. So the solution for that is to implement everything in C and in C++ and call C, C++ code from other languages. It's kinda what libraries like TensorFlow or PyTorch are doing. For example, TensorFlow, it's also written in C and in C++, mostly to speed up development, but also to reuse the code. And but your work, when you're writing code in TensorFlow, more likely use Python. And here it is the same. There is C and C++ code behind the scene, but as a user, you are working with Python most of the time, with Java, C#, and so on. And there are 3 main components, as I said, like data acquisition API, signal processing API, and a new model called ML model. It's the newest one. It's not so well developed as 2 other models, I would say. And in terms of structure of the code, it looks like this. There are 3 main classes in the user code. Actually, as a user, you're communicating only with black boxes on this screen, with board trim class, with data filter class, and so on. Yellow boxes on this screen, like low-level API, and yellow boxes are, in fact, dynamic libraries. And if you take a look at board controller blocks right here, I don't know if you see my mouse, you'll understand how device abstraction is implemented. So there is a factory, there is like uniform interface directly in C and in C++ code, and there are board classes that implement that interface, I would say. Let's go on. Installation and code samples. And yeah, let's go to this link first. And it is linked to BrainFlow docs. As I said, here you can check all boards. And when you start working on BrainFlow, it probably will be the first page you should check. And especially because of the tables, they actually tell you how to pick specific board using BrainFlow API. I will show that a little later. Also, there are installation instructions for different programming languages, for Python, C#, Julia, MATLAB, and so on. We will start with Python because I think it's the most popular one and the easiest one. And there are multiple options how you can install that package. The first one is to compile C and C++ code by yourself first. It's especially popular for those who make changes in brainflow code. But also you can install that from piping. And let me do that. Installation from pipe is like for any other package you can type stuff like that, and it will install latest brainflow release. For me, it's already installed. Yeah, and when you install that from the pipe, you do not need to compile C and C++ code because there are precompiled libraries in WHL file actually. But these precompiled libraries cover most popular operation systems and CPU architectures. If you are using something like Raspberry Pi or NVIDIA Jetson or something specific like Linux plus ARM 32 bits, for example, there's no precompiled library for that type of architecture. And then you need to build the code. Building the code is pretty simple. You need to run something like that and wait a little for C code to be compiled. And let's go to code samples. Let's copy past one of that. It's actually the first sample. It shows you how to get data from supported devices. And we will run that. I will close all of that. No. And yeah. I just copy pasted this sample from Brainflow docs. You can also find that in the repo. And let's take a look at that first. This here is the key part, and everything else is just the preparation. So there are like 10 lines, or even less lines of code if I remove comment out options. As I said, API itself is uniform. So in this method, there is no device-specific API calls. All of them are uniform, and there is nothing. Yeah. But you also need to select a particular board, and for that there is an idea of board IDs. It is int or inner value that you need to provide. And also for some devices, you may need to provide additional information. For example, for OpenBCI Titan, you need to provide serial port. For Muse, you may want to provide MAC address of Muse device to find, and so on. And all that type of info, device-specific info, that's actually the only part that is different between different devices. That's done by brainflow input parameters and port ID. Everything else is common. And let's run that for synthetic board first. For synthetic board ID is -1. In the code, you should use that as enum, but from the command line, you can provide it as an hard-coded int, like I did here. And currently, this code establishes a connection with the board. For synthetic board, of course, it's auto-generated. There's no connection. It waits for 10 seconds, and after that, release the session and prints the data. And data in Brainflow is just an array standard. There's no own data types, and it's really cool because it allows you to for example, it allows you to use Brainflow for data acquisition and something like M&E for signal analysis. Since in Brainflow there's no one format, it's just an array. You can easily convert this array to M&E format and do whatever you want with it. And let's also clean up this code a little. So as I said, all these code is just to make it generic. It's actually not really needed if you know that you will work with a single device. For example, if you bought Cython and want to do something with that, all of that is not needed for you. You can remove that, you don't need that, and so on. You need to provide board ID for your board, and to do that, you need and let's run synthetic board because I do not have hardware connected right now, so all demos will use synthetic board actually. And that's all you need to write to get data. Let's run that also. Yeah, and as you can see, the basic example is very simple. If you remove all boilerplate code about dark parse and so on, it will be just 5 lines of code and pretty simple lines of code. If you want to use real board, you'll need to change the board ID, as I said here, for example, to Cython, and also you'll need, as I said, provide a serial port parameter. That's done by params serial port, and here you need to write your COM port for your particular device, something like that. For use, you don't need serial port. You will write here something like serial number maybe, and provide serial number for your mute device. And here you'll need to write use S port or something like that. And let's take a look at another example with signal filtering, for example. I will also copy paste that from rainfall docs, and here you can see that this part is exactly the same. It was not changed at all. There is like extra method using rainfall login system, but basically it still calls prepare session, start stream, stop stream, release session. And also there is another demo here is how to convert that to pandas if you like pandas in Python, for example. That's pretty simple. And there is an example how to use different filters in Rainflow. They are different for different channels here, just for demo. There's no meaning in that. It's just to show more methods, I'd say. And Rainflow returns a lot of data. For example, in OpenBCI Titan, there are 8 channels for EEG, but Rainflow also adds extra information to these 8 EEG channels. For example, it adds information about package number, it adds information about timestamps, about accelerometer, and so on. And you need to use methods like get EEG channels, get timestamp channel, and so on to get information about to match this data to indexes, I would say. For EEG, it looks like this, and this. And let's run that also. Yeah, this example does not print the data to the console. Instead, it says that in pandas format, in pandas it will look ugly, but you can see that it works, and it is a synthetic wave with some noise, with different amplitudes, and so on. And there is one more example. It's like real-time plotting. Let's. I think it's also existed Rainflow docs like this one. It's and but I will run it from the repo. Python package samples plot real time. Yeah, it in real time visualize time series, and I provided board ID for synthetic board, so you can see 16 different channels because synthetic board in Rainflow has 16 channels. and they all have different amplitudes, different frequencies, different noise levels, and so on. So it's possible and pretty simple to use that for real-time applications, as you can see here. In these two examples, it was more like offline. So we run some code in another thread, like start stream. After that, we waited for 10 seconds, and at the end, we got the data. Here it is like another type of example. It runs that in a loop, and it is like real time. Let's move further. Yeah, and let's talk a little about other programming languages. For example, let's check code samples for MATLAB, maybe. Here is get data example for MATLAB, and as you can see, it is pretty similar to example in Python. It also has board stream class. This class also gets board ID and parameters as an input. There is exactly the same method like prepare session, start stream, stop stream, release session, and so on. This line, I think I was doing some experiments and committed that incidentally. It shouldn't be here, but yeah, it was something from the test. I will remove that. But API itself is pretty similar between programming languages, and it allows you to switch between them easily without any efforts, and you know what to do. If you learned Python API for BrainFlow, you should be also able to use Java, C++, C#, and other languages, because all of them are exactly the same. Let's move further. Here, I will mostly talk about the work done by other persons. For example, it was done by Matthijs. He also contributed to BrainFlow. He helped to refactor Julia binding for BrainFlow, and for these demos, he actually used Julia. He also talked about that at PyData conference in local one in Eindhoven this year. And he wrote a really cool article. Let's check that. Here he used BrainFlow, and he used armband from OY Motion. It is Chinese company. And I especially like this part that before BrainFlow he was trying to do that, and it was really challenging. But here he shows how to use that using BrainFlow API. He also has some notes about classifier itself and how it works. So feel free to check this article. Here is a simple Julia visualizer, also written on top of BrainFlow, and you can see it here how it works. You do different arm gestures, and you can see different types of signal. So you can train a classifier on the data, and it is exactly what's done here. There are multiple options to integrate that into games. The first one, and the one represented on this slide, is just trigger keyboard press events. So if you have a game and if you have something like armband or EMG-based controller, you can, roughly speaking, programmatically send events like keyboard press, and this way you can control the game. It is the easiest option. It does not require you to write your own games, and that's really simple to implement, fastest option and so on, but of course functionality for that is very limited to what you can do using keyboard press. Yeah, and let's check how it looks. So if you have a runner like this one, you can train a classifier and attach keyboard press events to that classifier. That's how it works here. And it works good enough, I would say. Uh, but as I said, if we're talking about game development, what you can do using that approach is limited by keyboard. And let's move further. Yeah, second option. You can create your own games from the scratch. Uh, this way you can do really whatever you want. You're not limited by keyboard press events. You literally can implement whatever you want. You can change the game world as you wish without any limitations. But the problem with that, it's developing games from the scratch is pretty challenging. Uh, and it requires a lot of efforts to do UI, UX, graphics, and so on properly. In Brainflow, we have docs how it can be integrated into some game engines. Here we have docs for Unity, Unreal, and CryEngine. But technically, you can integrate Brainflow into any game engine, at least if this game engine uses Brainflow supported programming language for scripting. For example, there is a relatively popular game engine called Godot, and for scripting it uses GDC. Brainflow does not support GDC, and so it means that from the box, Brainflow will not work with game engines like Godot. But of course, there are some options to integrate it using C++ API because almost all game engines are written in C and in C++, but they will be more complicated. Yeah, let's take a look at these docs for a while. Let's start with CryEngine. CryEngine is a pretty cool game engine, but it's focused on professionals, I would say. It's not for individuals trying to experiment with that. It's mostly to develop like AAA games, first-person shooters, and so on by professionals. It uses C++ and it uses CMake as a build system. Brainflow provides CMake package when you install that from the source, and in CryEngine it's extremely simple to integrate Brainflow into that since they both use CMake. For Unreal Engine, it's a little more complicated. It's also written in C and in C++, but in Unreal Engine there are also blueprints. I mean, you can draw some boxes and connect them with the arrows and so on. There are no blueprints for Brainflow Unreal Engine plugin, I would say. Only C++ API is supported, and here there is a special repo with some instructions how to do that. Yeah, and it's actually based on blog posts from Unreal, like how to integrate third-party library in Unreal Engine 4. So roughly speaking, you need to get headers from Brainflow. You need to compile that first to dynamic library, and in Unreal there is like its own build system that looks like C# code, I would say, and you need to register that properly. That's also more complicated than for Unity, for example, but it works, at least for me. And let's talk about Unity. It is like the easiest option in terms of integration of Brainflow, in terms of development, and so on. In Unity, it's very straightforward. Unity uses C# for scripting, and in Brainflow there is C# package. So all you need to do is to integrate C# package for Brainflow into Unity. You can compile C# package and C++ code of Brainflow by yourself, or you can download that from the Nugget. Nugget is a package manager for C#, roughly speaking, like Pipey in Python. Nugget, it's Pipey alternative for C#, I would say. you can download a utility called NugetExe, and using that utility, it's like PEEP, I would say. You can install BrainFlow for C Sharp. And Nugget package, in fact, is an archive. So when you download it, you'll see that folder structure looks like this. Let me zoom in. There will be a folder like lib, and inside lib folder there will be some C++ libraries like here, and there will be C Sharp library. And all you need to do is to copy paste C++ libraries and C Sharp library to a correct location in your Unity project. So here, let's assume that you created Unity project. You need to copy paste C Sharp library, this one, into assets folder, and you need to copy paste C++ libraries and other files like here to the root folder of your Unity project. And after that, you will be able to use C Sharp API for BrainFlow. All you can check code samples for C Sharp, like here. You can see that they are the same as for Python or as for any other programming language. And you're able to just use that in Unity directly. So you can create a game object and attach scripts into it. So here's an example how it can look like, very basic example that just prints something to the debug console. At the beginning, you need to call something like prepare session and start stream, and start in Unity is called automatically before at the beginning, I would say. And at the end, that's by the way extremely popular. Before the end of your scene, I would say, you need to call release session. And if you miss this call, you'll probably need to restart Unity player because otherwise it will be impossible to release that properly until you restart. So this part is really important. And it's up to you as a software engineer to call a release session for each prepared board. So on destroy method in Unity is called automatically at the end. And between these two calls, there is like update loop. And in update loop, you can do whatever you want. You can call get current board data, get board data, apply filters, and do other stuff here. Yeah, I think that's all. I do not have demos for that because games I was working on using that approach are not publicly available yet, so there will be no readers or screenshots, but later on they will be, believe. And the last part in terms of how it can be used in games. It is about game mods. This particular example was done by Marius. I don't know, maybe he already presented something today, or maybe will be, or maybe you're already familiar with that or not. But personally, I think it is a really cool approach for BCI plus gaming, because this way, I mean, we cannot create a cool game by ourselves. It requires a lot of resources. So even if we create a game using approach I showed previously, it will not be able to compete with AAA games like Skyrim and so on in terms of content, because we just do not have enough resources to do that and do not have enough experience. Really, AAA games should developed by big companies, and for majority of us, I believe it's not an option at all. But what we can do is that we can take existing game and integrate BCI functionality into it using different game modes. This way, we do not need to worry about game world recreation, about graphics, about gameplay, and so on. All we need to do is to think how to integrate BCI functionality into that particular game. And in terms of idea, at least, it's way more easier than trying to recreate the game from the scratch. Unfortunately, game mods are pretty difficult to develop. How standard game mod looks like? You need to create your own dynamic library. This library usually hooks some methods of the game, and there is an injector. So you start the game, and injector loads your DLL into game process. So it means that typically game mods are implemented in C and in C++, and they look like dynamic libraries. And C and C++ are pretty complicated programming languages, so you cannot do that in Python or in MATLAB. You more likely need to use C++ API. But if you do that, you really able to integrate cool BCI functionality into game that supports mods. And if I will run this video, here's a link to this mod. It was really popular on the internet. I saw posts about that all over the internet, I would say. And it's one of the videos made by Marius. Maybe you already saw that, maybe not. Let's take a look at that.
Hello everyone, this is Kangar. Welcome back to... Really? Hello everyone, this is Kangar. Welcome back to Skyrim VR Mods. Today I am going to show you a new update of my brain-computer interface mod. You will see a few new features of both the gameplay and the BCI part. Alright, so here you can see the first new feature, and that is this brain bar. That is technically a feature of Spellwheel VR, but Shizov has made this specifically for Real Virtual Magic, and it's compatible now with the latest version. And this shows the actual brain meter in action, and you can see while I'm talking with you, I'm slowly losing my focus, and the meter will pick this up. If you want to use the Spellwheel VR bars exactly as I have them on my right wrist on top, then you should use these values on a right wrist top, and then this offset and the angle, and also the bar view angle like this. So these are the values that work well for me. You might want to have different ones and so on, but this is just what I suggest. And now you can already see the second feature, and that is the Magica bar right there, right? This is no longer the actual brain power. So this used to be the way in early versions, and now in the new version, this is just a normal Magica that you have. So this is not changed anymore. This is 100 Magica because I have a brand new character here right there. And now the brain power will actually affect the Magica regeneration. So this means if you lose focus, you actually lose Magica, but only as part of a regeneration. And then if you gain focus again, your Magica will slowly fill up again. And as I said, this is still my regular Magica. So the only thing that really changes now from the mod is the regeneration. And in addition to that, it also changes the spell power, not only of the damage, but now also for all other magic powers like restoration, conjuration, and so on. So this was not the case earlier, but now whatever you do with magic will be influenced, and it will be either reduced or increased in power depending on this exact bar. And then I have one new feature that I cannot really show you because the mod is now compatible also with regular Bluetooth. So you do no longer need a Bluetooth BLED112 dongle. You can use any Bluetooth. You can use built-in Bluetooth off your PC or a regular Bluetooth dongle or whatever. I should note that the Bluetooth of the Muse is really weak. So you should try to have it as close to your head as possible. However you want to establish the connection, it should be really close to your head, either with a USB extension cord or the way I have it, I have the Bluetooth dongle plugged into my Valve Index. This may or may not work for you. I have one report of a person where this was maybe overheating or something and then didn't function anymore. But whatever you do, you should have the Bluetooth connection as close to the muse or to your head as possible, as otherwise the connection might be unstable and then the game might crash or your PC might burn or something. I don't know. The latter is probably okay. That was not intended. I wanted to say that the latter is probably not the case, but maybe the game has a different opinion. Anyways, the last thing I want to show you is this. So this is the ini file of the mod. And here you can see I added parameters for the BCI processing. So this is the history length. That is in steps of 1.2 seconds. That just means how fast your current, like instantaneous brain power affects your in-game brain power. And this means that I have a moving average of 30 seconds and older values don't count as much as newer values. And you can play around with that. That just means like it's changing more immediate with what happens. And then you have the brain offset. This is a value that is just added to your brain power. It should be in the range of plus minus 0.5 or something. I would say it depends a lot on your actual brain and on your skull and a lot of other things. So essentially, if this value is larger, it's easier to get the full brain power, and it just increases your overall brain power. And then here we have the brain scale. So this just shrinks or increases the range the brain power from the device is getting. So if you have this very large, then it's very easy to reach the maximum and the minimum, but you might be just flipping between super powerful and super non-powerful. And if you have this very, very small, then not much is happening. So these are the values that work for me personally, but you might have different values, and it's totally fine to change that and play around with that. Yeah. And here I have values for adjusting the minimum and maximum magica regeneration, and also the minimum and maximum spell power. So this is in percentage both. So minus 3% of your max magica per second, or plus 7 of your max magica per second when full power, full brain power, when no brain power. Minus 100% of your spell power, so no spell damage or no healing when you're super non-focused, and double damage when you're super focused. This is obviously subject to change, and this also depends on what you want. I'm just using these values here as a default at this point. All right, so that was the update for today.
Wait a minute. Let's take a look at BrainFlow section at that site. Here you can see that there is board ID provided, and 38 is for Muse S, and there's also a few more options. I think serial port ID is something for BLED dongle, if I'm not mistaken here. Let's continue.
And this also depends on what you want. I'm just using these values here as a default at this point. All right, so that was the update for today. I really want to thank everyone who's watching my videos, who shares them, who likes them, and who joins the Discord. It's so great for me to have this community, to see how excited you all are about what I am excited about. This is fantastic for me to experience, and I just hope that I can live up to the excitement I generated with you. And as you can see, I am actively developing the mod. There's a lot of stuff going on behind the scenes. Come to the Discord if you want to stay in the loop. And it's really great to know there are already people playing with this mod. So I have 5 testers or something like that at the moment who already have the Muse device at home and who already played the mod and it worked for them. And I'm getting a lot of feedback there about what would be nice to have and how things do not work and so on, and trying to adjust for everything. So yeah, just thank you everyone for making this possible.
Yeah, and as I said, it was not me who implemented that. It was Marius. It's a great job. Yeah, let's move on.
Hello, everyone.
Yeah, and as conclusion, Rainflow can be used for game development with BCIs, and we're looking forward for new code contributors. So if you help us to make it even better, add new devices and so on, that would be great. And I think that's all for me. And as far as I understand, we have 10 more minutes. Maybe now someone has questions. That's a great time to ask them.
Thank you so. Oh, I'm muted.
Looks like there are no questions.
Yep, sorry, I was muted at the time. Thank you so much for your talk. It's, yeah, it was, I know it's a hard time right now, time wise for you, and it's getting pretty late here as well, so I know quite a few people said they were going to check it out on the YouTube link. I don't think we have any questions right now, but thank you so much for your talk. I know it was talked about earlier tonight as well when Kangar, who makes Real Virtual Magic, spoke at the beginning of the event night. So he talked a bit about BrainFlow as well. And yeah, it was really good tonight to go full circle from someone building an app then to the deeper level stuff. Um, yeah, we have few people waving by. Yeah, thank you so much for coming out to speak virtually. Yeah, there were a few audio issues. I think it might have been on Google Meet's side, but the visuals and everything worked properly. Um, I also have a recording that I'm going to, because there were a few dropouts on the live stream that I'm going to re-upload after a bit of editing and audio tweaking. But yeah, thank you so much for coming by. I hope we can do this again sometime, because getting people to use BrainFlow is a very, very exciting thing for game devs and for just brain and people who like BCI in general. Yeah.
Cool. Thank you for inviting.
Yeah. Yeah, I'll talk to you around. Thank you so much. Have a nice morning or night. I'm not sure what time it is there.
Yeah.
Bye.
Bye.
I don't know. I turned the camera off part way. Yeah, but a lot of people who weren't able to make it today because there was another party happening all said they wanted to watch the YouTube